Okay, everyone. Welcome to week 5. We're talking about soils and natural hazards here, and this actually flows somewhat naturally from our landforms material from last week, and then into the natural regions material for this week. So you should check Blackboard in the week 5 folder for more info about natural regions. Also, by this point, you should be into the wiki assignment, so don't forget about that. Okay, so in Latin America, soils are actually pretty important, and they flow from landforms or come from landforms because different landforms help produce different soil. Now, when we talk about soils, I always try to emphasize the fact that soil and dirt are different. Soil is not dirt. Soil is actually the key to successful agriculture. It's also the host to an insane amount of life, just incredible amounts of life. A tablespoon of soil can have millions of bacterium. It can have lots of different fungi. It can have a lot of different protists, which are these kind of microorganisms. So they're not unicellular. They're multicellular organisms. And it can have, it's basically a medium for life, whereas dirt is just anything filthy, right? Now that can include soil that's in the wrong place, like on your kitchen floor, but soil and dirt are not the same, so they're not synonymous. So I encourage you to think about, just to be a little self-aware when you say the word dirt, do you mean soil or dirt? You don't plant, vegetables or flowers in dirt, you plant them in soil. There are a lot of different things that give soil characteristics in different places. Some of those things relate to the parent material, like I said before. If something's limestone underneath, it's going to have an impact on the soil. It can be the organic matter on top of the soil can contribute. So we're looking at a soil profile here, and you can see there's different banding. There's organic matter on the top. It looks a little clayey. All these characteristics are pretty important, and they're all kind of governed by the process of soil formation. Now, I sometimes joke, because there's not an easy kind of acronym or kind of mechanism to remember all these things. So I kind of joke about CLORPT. Basically, soil is formed through interactions of climate, organisms, relief, parent material, and time. So each of these are pretty important, and soils are the results of kind of all aspects of the physical environment, and actually can include human activity too. But let's address each of these in turn. So climate. Well, climate, we talked about climate 2 weeks ago. Basically, you have temperature and precipitation are kind of the main controls on climate, and that climate actually correlates with soil types all around the world. So a lot of this is due to the fact that moisture, evaporation, and temperature are all part of climate, and all of these have significant impacts on chemical reactions. So, the organic activity in a soil, the weathering of a soil, or the decay of a soil, the breaking down of bigger chunks of things into smaller chunks, and then the chemical reactions by which the chemical constituents of soil change into other things are all regulated and modified by climate controls. Also, climate has a huge impact on glaciation, which moves soils around and crushes bedrock, which is parent material, right, into soil over time. The next one, organisms. Well, organisms include everything from bacteria all the way up to advanced omnivores like human beings, right? So just some examples. Trees, like evergreens in particular, so pine-type species, they can change soil characteristics by contributing to soil acidification. And it turns out that pH is a big factor in vegetation growth, so therefore, if you have, say, evergreen trees established in an area, they can actually bias the soil so that it won't support other types of plant life. Civilizations can completely change soil characteristics over really big areas. So if we think about mining, we dig things up, we change the soil structure. We're actually going to discuss this in a second, in terms of how human beings have influenced actual soil types in some places. Believe it or not, worms here in North America, so these are organisms, right? They're actually part of the Columbian Exchange. There were no earthworms in the New World before the arrival of Europeans. That blows my mind every time I read it. But their arrival from Europe changed our soils a lot. And then finally, bacteria, or actually rather the lack thereof, can really affect things like the decomposition of organic material into soil material. Relief is one of the factors here, and that can have a significant impact on soil formation as well. Steep slopes can't support full soil development because their angle can't support heavy, full thickness soils. It just kind of sloughs off, and therefore slope can have an impact. Flat areas can have drainage issues. So think about like extreme northeastern Indiana. It's a pretty swampy area. It's not as friendly to agriculture because we have trouble getting drainage to happen. And this drainage can lead to soils that are inundated with water all the time, and that impedes soil formation. Or it can lead to the formation of different types of soils, like bog soils or muck soils. And then finally, relief. So how much elevation there might be, related to relief, there's aspect. So that's the compass direction a slope points in or faces towards. That can have an impact too, because south-facing slopes get a lot of energy from the sun, and that will speed up decomposition or chemical changes, right? So that's actually true in the northern hemisphere, so places like Mexico and Central America. But the opposite, of course, is true in the southern hemisphere. North-facing slopes will get more sun, right? Then there's parent material, and this is a big one. It refers to kind of the raw bedrock ingredients of soil, and it usually comes from the subsoil. We'll call that sometimes the upper lithosphere. And this gives soil its chemical composition, its texture, and these all influence the base fertility of this soil, right? So things, and also things like pH. And then finally, time is a big factor. All of these processes operate on geologic timescales, not human ones. So soil formation can take hundreds to thousands of years. And once a soil is formed, it doesn't just stop changing. So the characteristics of our physical environment are always changing, and that includes soils. So in a few hundred years, it's actually conceivable that soils in our most productive places here in North America will be unable to support corn production, right? And that's because of how much we use them. Even with petrochemical inputs like fertilizers, we might not be able to because we are abusing some of the other aspects of soil that are necessary for plant growth. Time also allows for erosion and weathering of soils, and we'll talk about that too. So basically, if you're looking for anything in Latin America that is an example of how all of the physical processes of the environment work together to change something, soil is the one. Okay, in Latin America, there are some challenging soil types that would be challenging for agriculture and some kind of naturally fertile ones. Some of the challenging ones are oxasols and ultisols. Now, sometimes these will be called latisols, and they're just really old soils that aren't very good for agriculture. They're weathered. They've had a lot of the nutrients leached out of them. And because they're old and they're in very wet areas like the Amazon, they don't have much in there. They are very rich in bauxite and iron, and they're really high in phosphorus, which is important for plant growth, but they have too much phosphorus. So it actually, even though it's an important nutrient for plants, it's actually somewhat toxic for them. And the only option for good agricultural yields in this part of the world with oxasols and ultisols is a lot of fertilizer and a lot of application of lime, which can help change the pH to be more favorable. Aridisols are next. We find them in, yeah, you guessed it, desert areas. So they're desert soils. They need lots of water for agriculture, but when you water them a lot, they're very productive. But by watering them, you can have issues with salinization, the salting of the soil, which occurs when irrigation water evaporates, leaving behind the salts that were in the water, which poison the soil. And this is actually a problem that people have in Argentina and some parts of Peru and also Mexico, where irrigation has basically ruined these soils. right? We find these in dry parts of Mexico, Argentina, Brazil, Peru, Bolivia. Then there's spodosols. Now these are leach soils in wet areas. They're often used for forestry purposes. We don't find a lot of them in the U.S. They're not good for agriculture because they're flooded all the time, but they are good for things like timber production, right? We have a lot of these in the northern U.S. and in Canada, not so much in Latin America, a few places down in the very tips of Argentina and Chile. Now there's some naturally fertile soils too in Latin America. The top of the list, we have mollisols. These are really great soils for agriculture. They're grassland soils. And they're really highly fertile because of the addition of organic material from grass roots built up over thousands of years. So they're mid-latitude soil, so you don't find them in the tropics, but we use them all over the world for agriculture, and they're really important. In Latin America, you find these in the Argentine, Brazilian parts of the Pampas areas, Peru, Ecuador, Colombia, Central Valley of Mexico, which is very agricultural. Then there's andisols. We find these, they're totally volcanic soils. They're formed from volcanic ash and just other stuff a volcano kind of belches out. Latin America has some of the most extensive andesol areas in the world, especially when you consider that this is the least common soil order all across the world. It can be very fertile, but it can also be hard to farm because remember, altitude makes things cooler. Volcanoes that have large andesol soil areas on them tend to be tall. And so it could be very difficult because of coolness. And then, of course, you're always at risk of the thing blowing up, right? These soils could also be in very dry areas. And if you water, then salinization could be a severe problem, right? Find these in southern Mexico and in the Andes quite a bit. Then there's alphasols. They're medium-aged soils. They're really good for agriculture. Partially because they're located in really good places for agriculture, climate-wise. In Latin America, we find these in Bolivia, Paraguay, Argentina, Brazil, Mexico, Guatemala. You actually find them in northern Indiana a little bit too, and southern Michigan has them. They require light applications of fertilizer to maintain yields, otherwise they're pretty low maintenance. Then we have fertile soils like enthesols and inceptisols, and they're barely formed soils. They're not weathered, and they're very fertile, but they're often development impeded, meaning that they have high water tables, and sometimes they're inundated, which makes them really hard, makes it hard for organic matter to break down and be incorporated in the soil. Along the Amazon floodplain, we see these inceptisols, where the river floods and leaves behind a new soil layer every year. That's enthesols, new soils. Inceptisols. Inception, right? Inceptisols. Enthesols are the kind of weird leftover soils that we can't figure out exactly how to classify. They're kind of like the soil fudge factor. All of these soils kind of work together to obtain natural regions. Now here it says rely on the handout. I forgot to change this. Actually, you should go to the online map that helps you. You can go and actually click on these and see where their extents are and sort of some basic characteristics. But definitely check out the natural regions, because when you combine climate with soil and landforms, you end up with this kind of very complex patchwork of natural regions that really influence vegetation and agriculture. One thing I want to say about this kind of vegetation and agriculture thing is that there is such a thing as anthropogenic modification of soils and vegetation types. And this is something that's a little bit controversial, but evidence is pretty strong now that this is a pretty significant part of the vegetation, the native vegetation in Latin America is at least partially anthropogenic. Well, what that means is that since people have lived in the Americas for up to maybe 30,000 years, maybe even longer, but at least 13,000 years, we've had a huge impact on forests and other environments. And one of those impacts could be how we tend to be when we live in a place for a long time. We're selective in terms of what plants we use. Often, kind of encouraging some plants to grow and kind of trying to get rid of others. And so over a 30,000 year time period, say, this can actually lead to entire forests having an unreasonable or unusual number of plants that are useful for humans. And so we actually find in some places like the Amazon and some upland areas of the Andes that huge areas are actually have unnaturally high concentrations of useful plants. Some estimates say that up to 11% of the Amazon forest is actually anthropogenic, in that, you know, native groups have been selectively managing it for a long time. And actually there's mounting research that shows that people have been modifying the environments of the Amazon for probably at least 15,000 years. Now, just by way of an example, this is a picture taken on the island of Marajó, which is at the mouth of the Amazon. It's a world's largest freshwater island, and near the city of Belém in Brazil. And these two young guys, they're on a log bridge here, and it looks like they're standing in the forest, and they are. But, you know, yeah, these children they're surrounded by trees, but almost all of these trees are useful, including mangoes. You can see these mangoes kind of hanging here. Tasty, right? And then some of these taller trees are ipe trees, which are medicinal. We have some acai, which is this palm that's kind of peeking into the photo here. Almost every one of these plants is useful for people. And they didn't plant any of these. This is just the way it was. So people have a pretty big influence potentially on the natural environment. All right, let's shift gears. We're going to keep talking about people in the natural environment, but let's talk about natural hazards for a few minutes. Well, we've talked a little bit about these already, but we're going to walk through some of the ones that are most important. Right now, all the problems that Latin America and the Caribbean tend to have with natural disasters are mirrored in this country and throughout much of the rest of the world. We share these problems, right? But Latin America often has some of the most severe instances of natural disasters, at least when you consider human suffering, right? There's some notable exceptions like earthquakes in Sumatra and Pakistan, the tsunamis that have occurred over the last couple of years, volcanic activity in the South Pacific. But here we're going to be talking about what makes people in Latin America vulnerable to natural hazards in comparison to other parts of the world, right, including the Great Lakes region. There are also a number of issues that we didn't discuss when we've talked a little bit about Mexico, Central America, etc. And, you know, some of these, we've talked about volcanoes a little bit. I've mentioned like a hurricane here and there, maybe an earthquake. There's other stuff, like this is a landslide that hit in El Salvador in 2001 and wiped out part of a town. These are pretty common occurrences. Now, if you want to gather information about, you want to gather information about natural hazards in Latin America, one good source is this Geology Department website here. It's at Michigan Tech University. And this is the Remote Sensing for Hazard Mitigation and Resource Protection in Pacific Latin America. It's actually a National Science Foundation grant that's encouraging international research experiences for undergraduates at Michigan Tech. But they have some pretty neat resources here on the project resources page that could be of interest. There are amazing volcanic and other natural hazard potentials in Latin America, and some of them are really beautiful. This is Santa Ana volcano in El Salvador. And really overall, volcanoes are a pretty important issue in Latin America, right? So we think about volcanoes as being dangerous, but living by volcanoes, it's not all danger and lava all the time, right? I mentioned this a little bit. Volcanoes can impart soil fertility, but basically, volcanoes can blow you up or burn you away. But once they're done, the stuff they leave behind are actually pretty phenomenal for agriculture. Not only that, but a lot of times, even after eruptions are taken care of, a volcano leaves you with not only agricultural capabilities, right, but also opportunities for geothermal energy. In the case of the Caribbean, many times they extend the land surface area and also can lead to opportunities for hydropower because volcanoes build mountains and then runoff gives you high energy potential for water. The fertility thing's worth knowing about though, because you see it you see agriculture extending up the side of volcanoes, like in this image. This is actually Volcan Galeares in Colombia. What would happen here? I mean, yeah, if the volcano went off, it would be a problem, but what would be the long-term implication? Well, you're growing your crops on the side of a volcano, it erupts, and your crops burn away. It can be very risky, so I'm not discounting that, but it's worth keeping in mind that we should probably realize that there's fertility and agricultural enhancements that come with living by volcanoes. Now, one thing that we should mention is that in Latin America is not actually the worst place on Earth in terms of natural disasters. All right, yes, between 1991 and 2005, the Americas were only second to Asia in terms of the total number of natural disasters. And many, many, many of these occurred in Latin America and the Caribbean. Well, wait a second. We were just talking about something called natural hazards, right? And now we're talking about natural disasters. Well, what is a natural disaster? Well, the official definition of the UN is actually an emergency situation posing significant danger to life and property that results from a natural cause, right? And that's a natural disaster, whereas a natural hazard is an environmental event which poses threat to life and property, right? So threat or danger. Well, essentially you can think of natural disaster as kind of the outcome of this equation. A natural hazard occurs in a place where there's vulnerable populations, and that leads to a natural disaster. So think of it this way. A tornado comes through a town, right? And that town has built all of its buildings underground because it knows that it's at risk for a tornado. That is a natural hazard, the tornado. But the population is not vulnerable to that natural hazard, and so a natural disaster is averted. Think of a hurricane. A hurricane hits a coast. Population is vulnerable because they have poorly constructed homes very close to shore. That natural hazard, the hurricane, combines with vulnerable populations to lead to a natural disaster. And what this means is that poor are disproportionately affected by natural hazards because their level of vulnerability is very high. So some have been well adapted, or able to adapt well to natural hazards in Latin America. Like in the Amazon, the floodplain, the river can raise by 40 feet without even it being weird during the high water season. And some people have adapted their lifestyles to become less vulnerable. But other folks are more at risk, right? It's very, very difficult to avoid being vulnerable to all types of natural disasters. Maybe you maximize or minimize your vulnerability to one, but you're still vulnerable to some. Now, there are a lot of different natural disaster types. There's hydrometeorological ones. You saw that in that kind of map/bar graph. And these include droughts, floods, temperature extremes, landslides, wind, fire, windstorms. They're basically, hydrometeorological means water-based or due to weather events. Why are landslides in here? Well, they occur when soil becomes so full of water that it turns basically into a liquid. Why is fire in here? Well, fire is generally driven by wind, right? And also can be driven by drought. And so that falls into the hydrometeorological category. Geological are pretty self-explanatory. We've talked about these: tsunamis, volcanoes, earthquakes. And then there's biological ones: epidemics, insect infestations. Human health epidemics are often linked to environmental conditions. So malaria, cholera, schistosomiasis, they're all environmental in one way or another. Insect infestations can lead to crop devastation, right? And this is really true in monocultural agriculture like we tend to practice in Latin America and the U.S. because there's not much competition, swarm behavior is more likely. And then there's plant epidemics, which have caused natural disasters when food security is threatened. Okay, well, if you look just from 1970 to 1999, right, now I know these data are a little old, but we see that really the big issue in Latin America are flooding. Now that's kind of crazy because we think of Latin America as volcanoes, earthquakes, flooding never comes up. And it turns out that worldwide, flooding is one of the most common natural disasters, right? There's some other important ones here: landslides, earthquakes, and drought, and then windstorms, of course. But, it's pretty interesting. A lot of times flooding actually is associated with the windstorm category. So natural disasters fall into this category most of the time in Latin America, and actually throughout the rest of the world. All right, we're coming down the home stretch, don't worry. Latin American hazards, there are a lot of factors that worsen natural hazards, turn them into disasters. So Latin America has substandard housing and a lot of people in poverty. There's a lot of marginality. In other words, people who are living in places that are not really suitable for human habitation. They're considered to be less than totally citizens. They're marginal people, right? Lack of building code enforcement is an issue everywhere, but really an issue in Latin America. There's almost no early warning coverage, although this has improved since the Asian tsunamis in the early 2000s. And there's a little bit of a sense of fatalism driven in part by kind of both a history of subservience to a colonial power, which leaves you feeling hopeless. So there's this cultural undertone. But there's also a kind of reliance on predetermination. I'm poor and that's how I'm going to be, or this is God's will. These sorts of attitudes that, especially among those who are marginal and poor, tend to lead to a lack of action to prevent hazards from becoming disasters. This isn't everywhere. Part of the problem is that there's no disaster management. So here in the U.S., but there's little disaster management. Here in the U.S., we have like FEMA, right? The Federal Emergency Management Administration. They distribute aid, trailers, temporary shelter. Doesn't happen in Latin America to the same extent that it does here. Now, in Latin America, we actually have had, over this same 1970 to 1999, an increase in natural disasters. Why might that be? Well, we have more people, right? Population's one reason, but also urbanization has led to the crowding of people into many places that are susceptible to natural hazards. Think about some of the largest cities in Latin America: Mexico City, Rio, Sao Paulo. These three cities are susceptible to earthquakes, more Mexico City, severe flooding, more Rio and Sao Paulo. Natural disaster events are significant. Between 1970 and 1999, there were 32.5 disasters in Latin America per year. And over this time period, there were about 226,000 deaths related to natural disasters in Latin America. Economic losses over the period range from $700 million to $3.3 billion U.S. per year. If we actually detrend this and we look at the number of people affected, we see these spikes. Why do you think they're there? Well, every spike was an El Nino year, which exacerbates extreme precipitation, making it worse, right? And this shows there's a direct link between natural disasters and hydrometeorological natural hazards, right? So just keep that in mind, that what nature does in its larger cycles can really affect human security. In terms of fatalities, it turns out that the number of natural disasters, okay, that's what this red line is, and the number of people killed in natural disasters aren't actually linked. So there's big spikes in fatalities, unfortunately, but they're like super severe events. So in 1970, down here, there's a huge spike. That's Chimbote, a Peru earthquake that killed 66,000 plus people. In 76, there's the Guatemala earthquake that killed 23,000 plus, almost 24,000. 1985, Nevado de Ruiz in Colombia killed 21,000. And then in 1999, there was flooding and landslides in Venezuela that killed more than 30,000, right? So the severity rather than the number is what's important. Of course, we can't ignore volcanoes. We've talked a little bit about many of these. So you've got lava flows, you've got pyroclastics, ash flows, lahars, and toxic gas. A couple of them we haven't talked too much about. One is ash flows, right? So they're a type of pyroclastic, really high temperatures. They're rapid and deadly. They look like this, pretty terrifying, especially when they're moving down the hill at 60 plus miles an hour. There are lahars, which are pretty unique to Latin America. They're a weird thing. They occur when a snow-covered volcano, which is pretty common in the Andes, heats up because of the volcanic activity, melts the ice cap really fast, and causes a huge mud flow of ash and mud. The stuff flows down. It's like concrete or like water and cornstarch mixed together. So it's a liquid when it's moving, but once it stops, it's rock hard. And this one, Nevado de Ruiz, which I mentioned a minute ago, that's this lahar here. If you notice, this is kind of the edge of a town over here in the back. This killed 25,000 people. An entire town was in the center of this photograph. Amaro, Colombia was washed away or buried in this lahar. Right? Okay. If we look at the deadliest eruptions globally, since 1500, the year 1500, we see that there are some pretty big ones, but only one of them is located in Latin America, and then there's another one located in the Caribbean, right? The Martinique, Mount Pelée. Why are we going on about volcanoes? Well, globally, Latin America is a pretty big world region for natural disasters caused by volcanoes. Two of the deadliest eruptions ever occurred in Latin America and the Caribbean. And many disasters can be predicted, like the hydrometeorological ones. We can at least have some warning. Volcanoes, not so much. And, that's kind of related to earthquakes, too. Peru, there was one in the mid-2000s, and these earthquakes cause other problems. So, including soil liquefaction, fires, landslides, tsunamis. They're pretty important. One thing, when you learn about earthquakes, you know about the Richter scale. Subjective descriptions, though, are sometimes pretty interesting. When the World Trade Center, the second tower collapsed a couple years, more than a decade ago, that was felt locally as a 2.3 on the Richter scale. And 3.4, you don't really feel that. It's a seismoquake. You only see it on a seismograph, right? By the time a Richter scale quake is measured at 5, you can feel it, but not too much damage. But just upgrade that to a 6, and there's a lot of damage, right? Most recent quakes in Latin America have been 7s to 8s on the Richter scale. In other words, very devastating. Of course, we can't forget about, and this is the last slide, promise, can't forget about natural hazards like hurricanes. Hurricanes hit Central America and Mexico constantly. They can also hit the eastern coast of Brazil. And now, with some weird climate shifts that are going on, we can actually get these on the west coast of Mexico as well. So very recently, in fall 2013, Mexico actually had 2 tropical storms hitting it, one coming from the Pacific side and one coming from the Caribbean Gulf of Mexico side. And, this is something that's kind of unheard of before. Of course, hurricanes can lead to strong winds that are damaging, floods that are damaging, and mudslides that are deadly. This picture here is Hurricane Mitch from 1998, and it killed the Yucatan. I mean, not literally killed it, but its secondary effects related to flooding and wind damage were way more costly than the actual storm itself. Anyway, that's it for natural hazards. But just remember, natural hazards plus vulnerable people lead to natural disasters. Natural hazards and natural disasters are not the same thing.